Welcome to the Explainer. What if a massive industrial turbine or an entire factory assembly line could literally just tap a technician on the shoulder and say, hey, my bearings are running a bit too hot today? Well, today we are exploring exactly how AI is giving industrial machines a voice through predictive maintenance. It's doing this by listening to the subtle hums, the vibrations, and the temperatures of equipment to stop multi-million-dollar failures before they even happen.
Okay, let's dive into this. We're going to cover the cost of downtime, what predictive maintenance actually is, how we're listening with AI sensors, turning that data into action, a real-world success story with Petronas, and finally, wrap up with the future of factories.
All right, Section 1, the cost of downtime. So imagine your car engine seizing up on the highway, right? You're stranded, you're missing work, and you are facing a massive repair bill. Now, take a second and scale that unexpected breakdown to a multi-billion-dollar petrochemical plant. It's a nightmare. When an industrial machine breaks down out of nowhere, it halts production, it completely disrupts global supply chains, and it just burns through cash instantly. The stakes of unplanned downtime are absolutely massive. Just how massive? Well, industry analytics show that utilizing AI-driven predictive maintenance can reduce the cost of unexpected downtime by up to 30%. Yet 30%. That is a staggering number, especially when we're talking about manufacturing facilities where literally a single hour of offline production can cost tens or even hundreds of thousands of dollars. It completely proves exactly why this technology matters so deeply to the bottom line of any major industrial enterprise.
Moving on to Section 2. What is predictive maintenance?
The paradigm shift we are seeing right now in global manufacturing is profound. For decades, the industry standard was reactive maintenance, that old school fix it when it breaks mentality. Or at best, they used planned maintenance, which meant servicing equipment on a rigid calendar schedule, whether it actually needed it or not. But predictive maintenance completely flips the script. Instead of waiting for breakdown or just guessing based on a calendar, we are servicing equipment precisely based on real-time sensor conditions. We're catching the subtle degradation of a machine and fixing it right before a failure ever occurs.
Section 3, listening with AI sensors.
I really love this quote from Sar Yaskovitz, the CEO of an industrial AI company called Augury. He says, when you drive your car, sometimes you can hear the fan belt is squeaking. Different malfunctions have very unique patterns. And honestly, it perfectly grounds this highly complex artificial intelligence in a super relatable everyday experience. Just like an experienced mechanic can hear a squeaky belt and instantly know what's wrong, AI algorithms learn the incredibly unique, complex mathematical patterns of wear and tear. But the AI is doing it at a scale and a sensitivity that human ears could literally never manage.
So the crucial point here is how the AI actually gathers this data, because it doesn't just look at machines, it listens and it feels them. AI endpoints are physically installed directly on the equipment to constantly monitor three very specific data points. First off, it analyzes vibrations. We're talking about the microscopic physical shaking of a motor. Second, it monitors temperatures, tracking thermal anomalies that would indicate friction. And third, it tracks magnetic emissions, which can reveal internal electrical irregularities. Then the AI uses deep neural networks to cross-reference all of these inputs simultaneously.
All right, Section 4, from data to action. We can actually break down this complex workflow into a really simple 1, 2, 3 process. Step 1 is the data collection we just talked about. That's gathering millions of data points every single second. Step 2 is AI pattern recognition. This is where the algorithm detects a subtle anomaly. A deviation so incredibly small, a human just wouldn't notice it. But Step 3 is where the magic happens. It's the prescriptive alert. The system doesn't just flash a red warning light and leave you guessing. It prescribes a solution. The AI sends an alert straight to a technician's mobile device, telling them exactly what's wrong, what the root cause is, and the precise steps they need to take to fix it. Because the ultimate goal of all this data processing is risk-based maintenance. Think about it as a spectrum. On the left side, you have firefight mode. That's under-maintaining assets, leading to massive breakdown costs and huge production loss. Then on the far right, you've got comfort mode. That's over-maintaining and basically wasting a fortune on completely unnecessary preventative checks. AI is what allows you to hit that sweet spot right in the middle, the absolute optimum balance between risk, cost, and availability. Section 5. Let's look at a real-world success story with Petronas. If you're not familiar, Petronas is a massive Malaysian oil and gas multinational, and they partnered with an industrial software company called Aviva to implement AI-infused predictive analytics across their highly complex infrastructure. What they did was feed real-time operations data directly into the AI, and the AI just started hunting for anomalies. Very quickly, the system caught these subtle irregularities in the water supply temperature combined with slightly increased bearing temperatures. Now, to a human operator, these numbers looked completely normal, but the AI recognized this specific correlation as a pattern, and it correctly predicted an impending mechanical fault. Now, what's really interesting is the hard financial return on that AI investment because it's staggering. By tracking these subtle thermal anomalies and catching just 51 distinct issues early in their very first year of implementation, Petronas saved an incredible $17.4 million. They completely avoided the asset failures, they eliminated the associated downtime, and optimized their performance. The whole shebang, all because the AI was listening so closely to the machines. And finally, Section 6, the future of factories. Whenever we talk about sophisticated AI analyzing data and generating instructions, the immediate question that always pops up is, how is this going to change human labor, right? Are the robots coming for the factory jobs? Well, the reality highlighted in our source material is that AI is actually acting as a co-pilot, not a replacement. AI is fantastic at pattern recognition when it has vast amounts of historical data. But if an entirely new, completely unprecedented era happens on the factory floor, something the AI has quite literally never seen before, it simply doesn't have the data to solve it. In those critical moments, human creativity, profound engineering experience, and complex problem-solving abilities remain absolutely essential to troubleshoot the issue. Ultimately, predictive maintenance represents this incredible shift from pure automation to human augmentation. It's giving maintenance teams the superpower to fix problems before the machinery even realizes it's broken. It really begs the question, if AI is mastering the heartbeat of our machines today, what entirely new systems are human workers going to be freed up to invent tomorrow? If you found this deep dive into industrial AI insightful, please make sure to subscribe to the channel for more explainers where we break down complex topics into clear, structured insights. Thanks so much for tuning in and keep learning.